All right, so today we are learning section 4.3, which is graphing absolute value functions with transformations. All right, so just a quick little review about absolute value function. This is the parent function for an absolute value, and remember that their graphs are in a V shape. Okay, so these should be mirror images of each other on both sides of the vertex, which is at 0, 0. Here's a table of the parent function for absolute value. And today we are going to talk about the transformations. So this is kind of like your little layout and guidelines for the transformations. Down here, this shows you guys what the transformations are based off of these A, H, and K values. So first off, let's just talk and say that HK is how you identify the vertex. So whatever that H value is, and whatever that K value is, that's what makes your vertex. So for an example, in the parent function, there's no H or K value. So that's why this vertex is 0, 0. Okay, there's no H or K value. All right, this A value. This A value tells you if you have a vertical stretch or compression. And so if the absolute value, which means take the A value and make it positive, if it's greater than 1, it's a vertical stretch. If it is less than 1 but greater than 0, it's going to be a vertical compression or shrink. However, whatever terminology you want to use is fine. Now, horizontal shifts are the H value, okay? So meaning left or right. Now, if this says X minus H, that means you're going to be moving to the right. If it says X plus H, you're going to be moving to the left, and that's because if there's a plus sign, that means that that H value is actually negative. So that can be a little tricky. So make sure when we get to the examples, we're paying attention to that. This K value tells you if you have a vertical shift, so if you move up or down. If K is positive, you're moving up. If K is negative, you're moving down. And then if there's a negative out in front of this A value right here, that means you're going to have a reflection over the x-axis. So it's going to flip, like you guys like to say. All right, so let's get to it. So it says find the vertex, HK. List the transformations, graph the function on the provided grid, and state the domain and range in interval notation. Interval notation, that's when we use the parentheses or the brackets. So that's this stuff. All right, so let's get to it. Example 1 here. All right, let's first identify this vertex. So my H and my K value. So there is no H value. So that's just going to be 0. And my K value is 2. So there's my vertex. All right. The transformations. Now, remember the parent function of an absolute value function is f of x equals just the absolute values of x. Okay? So notice if we look at the parent function, put PF for parent function, all right? There are 2 extra things right here compared to the parent function. There's the 1/2 and the 2. So that means I'm going to have 2 transformations. So I'm going to put 2 little bubbles so I know to make sure I state them both. Now this 1/2, that's your A value. So the absolute values of 1/2 is still just positive 1/2. And since that is less than 1 but greater than 0, that's going to be a vertical compression by 1/2. Okay? And then this plus 2, we already said is the K value. Here, I'll even write A and K. All right? So because it's positive, that means we're going to be moving up. So shift up 2. All right? Now we're going to go ahead and graph this. Well, I already know that my vertex is 0, 2, so 0, 2. All right. And then I now need to find my other points. So all I have to do is just plug in some values here for x and solve. So if I plug in a 1 right here, I'm going to get 1 times 1/2 is just 1/2 plus 2 would be 2.5. So 1 up 2.5. So 1, 2, 2.5 would be right here. Sorry, this grid is a little off. All right, if I plug in a 2 right here, 2 times 1/2 is 1. 1 plus 2 is 3. So 2, 1, 2, 3. Let's plug in a 4. Okay, so if I do 4 times 1/2, I get 2. Plus 2 is 4. So 1, 2, 3, 4. 1, 2, 3, 4. Right, that's a good enough of a picture there. And then because absolute values are a V shape, I can just take what I have on this side of the vertex and reflect it to the other side. So that's exactly what I'm going to do. 2 points away here, so 2 points away there. Now remember, this isn't 3, this is 4, so I need to go -4. 1, 2, 3, 4. There we go. I like to use my handy dandy ruler to make nice pretty lines. Alrighty. Make sure all your points connect. Nice and pretty. Alright, awesome. Okay, so as you guys can see here, if you compare it to this parent function graph up here, this graph shifted up 2 compared to this, and a vertical compression vertically is up and down, right? So if I'm looking at this from up to down, and you look at this guy from up to down, notice that he shrunk a little bit, or he was compressed down, okay? So that's a way to check yourself with your transformations in your graphs. All right, now the domain and range. So domain goes left to right, okay? So from the left, I have an arrow all the way over here, so that means I'm pointing towards -infinity. And then on the right-hand side, as I go across here, my function is continuous, and I'm pointing to the right, so it's +infinity. And remember, anytime you have an infinity sign, you're using parentheses. Now my range, I want to go from the bottom to the top. So on the bottom, my lowest y value is 2. And my largest y value, if I move up, both of these arrows are pointing up, so I'm going towards +infinity. Now for this 2 right here, since that 2 is part of the function, I'm going to use a bracket. And anytime I have an infinity, I use a parentheses. Alrighty, that's it for that guy. Example 2. Alright, here I have my vertex. Remember, that's HK. Oh, look, here's my H value. There's my K, that's where they would be. Okay, now this is a little funky here. This H value is not -2, okay? Notice that this is set up very similarly to this, all right? So this H value is actually +2, all right? And then this K value, there's nothing there, so it's a 0. Alrighty? And again, if I compare this to the parent function, okay, I have 2 things extra here. I have this negative sign, and then I have this -2. So again, I'm going to have 2 transformations. All right, this -2 represents a reflection over the x-axis. And then this x -2 right here, remember, if it says x minus, you're actually moving to the right because that 2 is technically positive. So we're moving, that's going to be a shift right 2. Alrighty. Oops, let me move down a little bit there. Okay, so here we go. I'm going to graph my vertex. So my vertex was 2, 0. And hey, if you guys compare that to the parent function, your vertex normally is at 0, 0, and look, it moved to the right too, so good job. Now reflection over the x-axis. Normally our graph points up, so now it's going to point down, all right? So basically you could just take these points from the parent function and move them right to, and just flip them over the x-axis, but we can also just plug in points right here. So I'm going to plug in 0, the x value of 0. So 0 minus 2 is -2. The absolute value of that would then be +2. +2 times a negative is -2. So 0, -2 is a point. Remember, I can reflect that over the vertex. So I'm 1, 2 spots away from the vertex, so 1, 2 on the other side. All right, and let's do one more point. Let's do 1. 1 minus 2 is -1. Absolute value, +1. But we got to multiply by a negative. So it's really -1. Flip that. I would like to see at least 3 points, 2 to 3 points on each side of the vertex just to get a nice pretty graph. And again, as you guys can see, this graph was shifted to the right too, and it is reflected over the x-axis. All right, let's do the domain and range. So the domain here is going to be from on the left, we have a negative arrow, so -infinity. On the right, we have an arrow, so +infinity. Range from the bottom to the top. On the bottom, my arrows are pointing down, so I'm going to -infinity. And as I work my way up, the highest y value is 0. Always use a parenthesis on infinities. 0 is part of the function, so I'm going to use bracket right there. Alrighty. Another example. Okay, I've got an A, H, and a K value here. Vertex. Notice this is not in the x minus h form, so I'm going to rewrite this as x minus h. Whoops. Now do you guys see how that's x minus h there? Okay, so that h value is actually -3. That's where that gets tricky. That's what I was talking about earlier. K value is -1, so there's our vertex. Transformations, you have 1, 2, 3 numbers that aren't in the parent function. So you are going to have 1, 2, 3 transformations. So the first one, the A value. The absolute value of 2 is just 2, which is greater than 1. So we are going to have a vertical stretch by 2. And then I'm going to have my H value. Oh, because the H value is a negative number, we're actually moving to the left. So kind of with my chart up here, that's why I put x plus h, you're actually moving to the left. And it's because, again, like I said, the H value is negative. So shift left 3. And then the K value, shift down 1 because it's negative. Alrighty. So -3, -1 is my vertex. 1, 2, 3. Boop. And then, again, you can just move these points from your table of values of the parent function, but you also can just plug in values here. I'm going to plug in a 0 for x. So 0 plus 3 is 3. Absolute value of 3 is 3 times 2 is 6 minus 1 is 5. So 0 is 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, let's do another number. Let's do a -1 right here. That looks good. So -1 plus 3 is 2. Absolute value 2 is 2 times 2 is 4 minus 1 is 3. So 1, 2, 3. I'm just going to reflect those over. So that's 2 points away from vertex. And this is 1, 2, 3, 1, 2, 3. Oh, perfect. That worked out really nicely. Always pick easy x values to plug in. Don't make it harder for yourself. Alrighty. And then your domain here. We go from negative to positive infinity again because we have arrows on both sides. Use parentheses with infinity. And then my range from the bottom to the top. So on the bottom, my lowest y value is -1. And my highest y value, they're arrows, so they're pointing up. So use a parenthesis. The -1 is included because it's a solid dot. And if you feel comfortable with these 3 examples, you can go on ahead and head to your homework problems. But if you would like to see 2 more examples with the transformations, I'm going to keep going then, okay? I've got just 2 more examples for you if you want to see them. Alrighty, so here our vertex, the H value is -1 and the H value is not -1. The H value is 1, okay? Don't get confused with that negative sign. K value is 2. All right, and I'm going to have 2 transformations here because there's only 2 different things that I see compared to the parent function. So this H value right here, that means, remember, we're moving to the right. So shift right 1. That K value is positive, so shift up 2. Alrighty, so I have 1, 1, 2. Alrighty, let's plug in a couple numbers here. Let's plug in a 0 right here. So 0 minus 1 is -1. When I take the absolute value, +1, plus 2 is 3. I'm going to reflect that. I'm 1 away, so 1 away there. And then let's plug in a negative. Yeah, let's plug in a -1. -1 minus 1 is -2. Plus 2, or I'm sorry, -1 minus 1 is -2. Absolute value of that is +2. Plus 2 is 4. 2 away from the vertex. Okay. Alrighty. And my domain is negative infinity to positive infinity. And yes, that's going to be it most of the time for the domain. It's the range you really got to pay attention to on these. So from the bottom to the top, my lowest y value is 2. It's included. And my highest y value is positive infinity because I'm pointing up. And as you guys can see, this graph shifted to the right one and up too. That's a way to check with your vertex, okay? On the example before, I forgot to talk about the transformations, but if you look at the transformations and compare it with a parent function, you would have seen all 3 of those transformations on that last example. All right, last one I have for you guys that we're going to be doing is this example right here. I've got an A, H, I've got no K value, but I also have a little negative sign, okay? So the vertex, remember this is x minus negative 2. 2 negatives make a positive, right? So my H value is actually negative 2. I have no K value, so that's just 0. Transformations, I have 1, 2, 3 things in there. So 1, 2, 3. The negative means a reflection over the x-axis. Then I have this 3, and this A value is negative 3, but when you take the absolute value of it, you get positive 3, which is greater than 1. So this is a vertical stretch. By 3. And then we have a shift left 2. You can think of that as because it says x plus 2. So you know you're moving to the left, or you can think of it as, oh, the 2 is actually negative. That's why I'm moving to the left. Whatever helps your brain. All right, let's plot some points. So negative 2, 0. Alrighty. I'm going to plug in a 0 right here. 0 plus 2 is 2 times negative 3 is negative 6. So 0, 1, 2, 3, 4, 5, 6. Oh, barely fit on the graph. So 1, 2, 1, 2. And I'm going to choose negative 1 just to make sure I can stay on the graph. So negative 1 plus 2 is 1. That's the absolute value of 1 is just 1 times negative 3 is negative 3. So 1, 2, 3. Oh, whoops. Move that over by 1. There we go. Let's graph that guy. Make it nice and pretty. All right. Domain, left to right, negative to positive infinity. From the bottom to the top, my bottom is negative infinity, and my top, that highest y value is 0. So bracket, parenthesis. And lastly, just to look, you can see that this is a reflection, the graph flipped. Then we have a vertical stretch by 3. Notice that the graph, if I'm vertically stretching something, like if I were to vertically stretch this pin and pull it, it would get skinnier. So you guys can see that this graph is skinnier than the parent function. And then there was a shift left 2. The vertex moved left 2. So that's a way to check yourself. Good job today, guys.